in my first loop, this was very simple. I said I have an array of integers, which is ArrayList, right? And dynamic array of integers. And I can extract my integers by using this enhanced loop. And then I said I can get the values and I can use them in my logic. The next thing is that I created this iterator and also created a standard for loop with no initialization. I'm done with my initialization prior to going into the loop. But the condition basically says has next. So once the iterator tells me that the next element does exist in this collection, it's safe for me to go into the loop. So has next returns true. So I jump into the loop. And then I say if the value is, so what I can do is that I do two things at once. Next advances the iterator to the next logical position inside my generic collection, number one. And number two, it instantly returns the value which is uh, which is uh, the iterator is referring to at the current time, at the current step of this loop or iteration of this loop. So interestingly, let's just make sure that we do print this exact same sets of data, 111, 111. So let's separate it by a space, right? So that we're not printing all of them jam-packed together with some spaces. And we should get our output, which is identical from both of these loops. All right. So here it is, the two identical outputs. We just reproduced the same logic. Of course, we never attempted to remove anything, so the result of that printed at the end is the same. But it's almost a counterintuitive type of thing. Besides saying next, and therefore having an ability to both advance the iterator and also examine the value, this reference to an object being pointed to at a time. There is this option to say iterator remove. Okay, so let's try this again, save it, and add this line, iterator remove. We'll run it. So look, it worked. The collection got reduced to the set of elements which does not include any 111s. So this thing worked. But what's the most counterintuitive portion of this iterator interface, this public way we interact with it, is that in addition to an ability to advance with next, and let me make it a little cleaner over here. So after saying next, we already said next, right? Right here, we said next, and it advanced the iterator, but it also gave us an integer. The remove will work. So there is another little hidden part in the iterator which points to the previous element, or somehow knows how to calculate the position of the element which was available before next. And that gives us an ability to remove the element. So this is the purpose of the iterator, that gives you this flexibility of both not just read only as the first example, as this first enhanced loop example, but both examination and removal. So in this sample, we did not use index. We only used the iterator. Of course, with ArrayList, You know, you could disagree. You could say, "Oh, look at this. This is by all means not a shorter version of the loop, so maybe I will prefer to use this." However, there are collections, and you on your own can create collections which do not provide access to your elements by index. Then, with those types of collections, using an iterator is the only way to go, right? If you need to modify your collection by executing the sequential search for certain values and potentially the need to remove them, using the iterator is the only way. Because some collections simply will not provide the get and remove by index as ArrayList does. So that's why the knowledge of the existence of this concept, the iterator, is very important, and you can use it on a regular basis. It's a very general purpose type of thing. Its its interface is very terse. Only three methods, right? Next, uh, has next first. Check if there's anything next, which returns true or false. Say next, which moves the iterator forward, but at the same time provides a reference to the element that you've been just referencing. And the only way that you may need to use the iterator related to that original position is that if you need to remove that element, right? To mutate the content and remove the element. And in that instance, you still have this remove. And so this is the way iterator gives you access to different parts uh, uh, in the collection. Any questions about this? This really just demonstrates it. I mean, you can probably find some other resources here. So we go to Google, and if we type Java iterator um, tutorial, something like that. So in the section that describes collections, it will be talking about the, different possibilities that exist uh, when you use the iterator, right? So uh, again, the um, uh, obviously you're gonna have to read the entire tutorial. I'm just trying to jump to the section where they talk about it. So here it is, right? Uh, the tutorial tells us that the iterator is an object that enables you to traverse through a collection and to remove elements from the collection selectively if desired, right? So this is this type of helper object that allows you to do both without any sort of index, because internally it maintains that index or whatever it's using to maintain its position relevant to your collection. And only three methods. Has next tells you whether the next element exists. Next advances and returns the reference to the current object, but also remove is something that will be able to retroactively say, okay, I can remove this element for you, which you already said next, but I still remember what it was, and it can be removed. Some of the collections actually may be providing only an iterator which does not know how to remove. And that would only give you a read-only access still to a collection. So some of the collections or generics can be so primitive that once populated, you cannot remove the elements. You need to remove the entire collection. In that case, if that type of collection still provides an iterator interface, remove may not be part of it. Maybe it be absent, so you can't remove. So anyway, these are the things about this interface, and it's an important topic because if you look at at code written commercially in Java applications, you'll see iterators all over the place. A lot of programmers will prefer to use the iterator in this situation as we tried here today, as opposed to using some sort of an index. Iterator is pretty efficient too. It sort of guarantees that the code that whatever you're doing with has next, next, and remove is going to be quite efficient. And I'll give you instantly another example where iterator becomes first choice immediately is when you, instead of using ArrayList, um, if you're using linked list. So if we switch to linked list instead of ArrayList, right? So if we switch to using linked list instead of ArrayList, in this case, this version of removal would still work because there's get and remove by index. But the problem is that every time you say get by index inside your linked list, you're going to sequentially navigate to that place from the beginning of your collection. Because list has to, in order to give you an impression of direct access to an element, it will have to start from the beginning and follow all the links from the beginning to the element which index you have provided. So this can be actually much slower. This version of the removal of elements that we try to use in the first place can be and will be much slower than the one using an iterator. So iterator is optimized to do all these things, and you should take advantage of it as the need arises. Yes, question.